The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Sorry for the miscommunication this morning. We are going to be starting in 1 minute. Hello, everybody. Welcome to day 2 of our 1-hour online training. Again, I'm very sorry about the miscommunication this morning. So our goal is to provide high-level overview of the IpTL devices. We're going to get into a little bit more detail today on some of the features and operation. I do not expect that you can walk away from this 1-hour training and go and set up complex networks to sort of give you an idea of the capabilities that are there, how we operate different network deployments. So today we're going to talk about setting up your gateways for your devices and how that affects your network. We're going to talk about tunnel failover. We're going to talk about the system monitor, system tools, and we're also going to discuss the authentication system. If you have any questions, just feel free to send an email to support@iptechnologylabs.com and we can reply. So the first thing that we're going to talk about is default gateways and DHCP servers. So we're going to talk about default gateways, just basic default gateway on a laptop, what that does, how that operates, what changes that makes to your network. Talk about in a multi-site VPN network or tunneled operation, how the default gateway of your devices changes the operation of your network. We're going to talk about where the DHCP server should be located on your network and how these decisions change how your network operates. So just a quick review of default gateway, in particular over a bridge tunnel. So the default gateway defines your next hop for traffic that's outside of your local network. So we have a little routing table on the bottom, and if you look at the 192.168.10.0 is on our uplink. The 172.17.22 is on our local network. So if the laptop, this is the routing table for the laptop on the left side. If he wants to send anything to the 192.168.10 network, he just sends it directly to that IP address. If he wants to send anything to the 172.17.22 network, it's connected locally to his device. He can just send it directly out. If he needs to send traffic to any other IP address, he will forward that to his default gateway. And then where your default gateway is defined, who your next hop is, that determines whether you're in a split tunnel mode or a compulsory tunnel mode. Typically, the default gateway for the laptop is going to be your local IpTL device or your remote router. So imagine that this is a bridge tunnel connection. So these devices all look like they're on the same Ethernet network. If my laptop on the left side, if his default gateway is the IP address of the IpTL device, then anything outside of the 192.168.10 network that he's a part of, anything outside of that network would be sent to this Model 71 IpTL device, and he would route it out as local ISP. That puts me in a split tunnel mode. If the default gateway for this laptop is the remote router, he can still communicate directly with anything that's on the 192.168.10 network. Anything outside of that network, he would send to the router on the remote end of the tunnel, and he doesn't even know that he's passing this through the tunnel because it's a bridge tunnel in this example. He would send it through the tunnel, and it would come out and go to the ISP located at the remote side of your tunnel. So now you're in a compulsory tunnel mode. So the two most common scenarios is my default gateway for my laptop, PC, servers, anything that you have. My default gateway is my local IpTL device. That puts me in a split tunnel mode. So I can route traffic that's not on the shared network out the local ISP. If I make my default gateway on the remote network, that puts me into a compulsory tunnel mode. So anything outside of my local network, I'm sending through the tunnel and out the ISP on the remote side of the tunnel. Now you could really use any access point as your default gateway. But the two that we discussed are the most common, but I want to walk through each of these different scenarios. So if I use my local IpTL device, set up in a split in an inline mode, so I'm connected to the local side of my IpTL device, his uplink is connected to an ISP or a local router, I'm in an inline mode. If I send traffic to him that's destined for the internet, he will route it out his local ISP connection. Now I could also set up that device in a stub mode. Single connection to the network. He's able to access the tunnel and access the local network, and I can make my local router my default gateway. So I'm still in a split tunnel mode, but now I've set up my local device, my device that I'm connected to, in a stub mode. I can set up the remote router as my default gateway. If I do that, this is typically how we would set up a server network. Server is in stub mode, single Ethernet connection to the network. Any traffic that's outside of my 192.168.10 network, I'm sending through the tunnel to the remote gateway, and he routes it out his ISP. And then I can also make my remote IpTL device my default gateway. It's not as common. Typically, your default gateway is going to be your local IpTL device or your remote router. So the DHCP servers, we've spent a lot of time setting up our devices so that they can be easily integrated into a network. So you can use the DHCP server that's on the IpTL device. You can use the DHCP server that's part of your network. Either way is fine. The one thing that I will say is when you're setting up a bridge network, just be careful that you do not have multiple DHCP servers all accessible from your devices. So now we are going to move on to section 2. Section 2, we're going to start getting into failover capabilities within the devices. So we're going to talk about the different failover support, define the basic tunnel failover, and we're going to talk through the bonded tunnel failover. And we're going to have some examples of setting up a very simple bonded failover between two different tunnels. So there's two different types of failover within the device. There's a data path failover and a tunnel failover. Data path failover is really handled by the system monitor. And when we talk about data path failover, we're talking about changes to the default gateway on the device itself, changes to the IP addressing or the routing table on the device. So your data path failover is how you are directing traffic, whether you're using the device as a router or whether that's a determination of where your tunnels are going to be connected to. But those are all handled by the system monitor. In the next section, we're going to talk about the system monitor. The tunnel failover defines changes to how the tunnel passes data within the system. The tunnel failover handles how you're reaching a remote end, whether you're in a standby mode, a hot standby, or a bonded failover, and what your fallback looks like. So our data path failover defines changes to the default gateway, IP addressing, routing table of the system. So it handles how you're getting to the internet, what routing paths you're using, which ISP you're using. Applications include, we can take a device that's set up for a compulsory tunnel mode, and let's say the tunnel drops or we get network traffic or network outage on the remote end. We can switch over to a split tunnel mode. We can fail over to Wi-Fi, fail over to an LTE. So based on a failure condition that's detected, we can change the data path within the device. So failover between multiple ISPs, failover to Wi-Fi, failover to an LTE. Any of these operational changes are all handled by the system monitor. And the next section, we're going to talk in a lot of detail on the system monitor. This is sort of just a quick snapshot of what the system monitor looks like, but we're going to get into this a lot more detail in the next section. So we can tell the device we want to fail over between a client Wi-Fi. So if our physical Ethernet port goes down, we can connect to a Wi-Fi network. We can connect to an LTE. So one of the capabilities that we have is you can have your LTE disabled within the device, so not using any data. If you get any network issues on your physical interface, you can fail over to an LTE interface. And then we can also make operational changes. So the system monitor will watch your entire network and then make changes to the device based on those error conditions. The tunnel failover defines changes to how data is passing through the tunnel or where the tunnel is being connected to. So we have a basic tunnel that we'll talk about, and we have a bonded failover, hot standby tunnels. You can fail over and fail back to your main tunnel. We're also going to talk about using the bonded failover tunnels or the bonded tunnels with multiple ISPs. So you can have failover set up where you're going through one ISP. You can have each tunnel going over a different ISP for failover scenarios. Typically, the failover is handled by the client side. So you would typically set up your servers. Your client devices would have multiple tunnels going to either the same server through different ISPs or going to different physical servers. And then depending on the server's availability, you're failing over between those interfaces. So we have a basic tunnel failover. We have a bonded client failover over a single ISP, bonded client failover over multiple ISPs, server failover, and setting up multiple physical servers. So if you go to the main tunnel page at the bottom where you set up your remote connection, there's a basic tunnel failover. So we're connecting, and we talked about this in our last session. We can define the server-side network based on the system ID or the MAC address of the server device. You can use a URL. You can also use a dotted quad format for your public IP or your server-side device. So the basic tunnel failover allows you, it's a single tunnel. So if I have a connection to this server device, UDP port 5150, if that tunnel goes down, it will reestablish a connection to the next tunnel that it finds. If this cannot make a connection, he will go to the third one. If that one can't make a connection or fails, he'll go back to the first one. So it operates very nicely. It's very easy to understand. The one main point is that it is a single tunnel. So if one of them fails, it will change the tunnel parameters and connect to a new server. So if your primary server comes back, it doesn't know that the primary server came back. It is basically just going on my tunnel is up or my tunnel is down. When we get into bonded failover connections for your tunnel, now we're talking about hot standby connections. So I've got a tunnel going to demo.iptechnologylabs.com with a failover or backup tunnel in a hot standby mode to failoverexample.com. If my primary tunnel fails, so the first thing to notice is that these tunnels are both up. If you looked at the traffic or you looked at the server side, you would see that the tunnel is established on both of the servers. Data is only passing through one of the tunnels at a time. So when I look at this scenario, if I had an outage at demo.iptechnologylabs.com, if this tunnel dropped, all my traffic would then be sent over the failover.example.com tunnel. If demo came back, if my first primary tunnel came back, traffic would be switched back to my primary. And that's all configurable. So I'm setting my bond mode for failover. I'm defining what my primary tunnel is. So, what the main tunnel that I want to use. And then I'm defining my recovery mode. So if my recovery is always, then once I go into a failure state, if my main tunnel comes back, I'll go back to my main tunnel. You can also set up the system where if he fails over to a secondary tunnel, he will stay there regardless if the primary tunnel comes back until that secondary fails. Bonded tunnels with multiple ISPs. So one of the things that you'll notice with some of our remote ports where we're setting up, this is a client device and I'm saying, here's the server network I want to connect to, here's the port I want to connect to. Within these brackets, these numbers is a packet marking. And what the packet marking does is internal within the device, it marks this packet as 15. It's marking these packets as 99. And then within the virtual routing tables, I can say any packets that are marked 15, I want to go out ISP number 1. Any packets that are marked 99 go out ISP number 2. So this is how you set up multiple tunnels, and then using our virtual routing tables, you can send each of those tunnels out through a different ISP. On the server side, there's multiple different ways that we can set up failover on our server devices. You can have a single ISP and a single tunnel. In this scenario, maybe you have your clients with multiple tunnels going through different ISPs, and you're really just trying to protect your client-side ISPs. I can have multiple ISPs all communicating with a single tunnel on the server side. We have multi-homing support, so if a tunnel comes in through ISP number 1, his return traffic will go out through ISP number 1. If a tunnel comes in through ISP number 3, return traffic will go out through ISP number 3. We can also set up our server where we have multiple tunnels and each tunnel is communicating with a different ISP. And really the decisions you're making here are, what level of failover, what level of high availability do you need within your client and server devices? We also have several capabilities to allow you to do multiple servers, and you can use a single ISP with multiple physical servers, or you can use multiple ISPs. Built into the devices is a VRRP support. So the two server devices will actually communicate with each other. And if one of the devices goes down, the backup device will take over and use the your virtual IP address. And there's a lot of information on our Techncial site about using VRRP. So we're going to do a very quick kind of high level example of setting up a bonded tunnel failover on a client device. So we're going to have two tunnels going to two different servers. We're going into the tunnel bonding page. So you go to tunnel bond, define our first server, define the first tunnel that we're connecting to. And we're going to say, we're sending traffic to this server, UDP port 5150, and we're going to mark all the packets with a 1. Then we defined our second tunnel. We're going to send it to this server, port 5150. These packets are all getting marked with a packet marking 2. Then on the same page, we are enabling the bonding system. We're setting them up for failover. We're defining which tunnel we want to be our primary tunnel and how we want our failover and fallback to work. Do we want to failover and stay there? Do we want to failover? And if the primary is reestablished, we fail back to the primary. Once the tunnels are established, gives you a system information. So we can see that we have 2 tunnels up out of the 2 tunnels that are configured. The bond mode is enabled. We're in a hot standby mode. If one of the tunnels drops, you can see we're in a failover mode. And it also shows you what your active tunnel is. So within the bond mode, my active tunnel is tunnel 1. If I go over into a failover, my active tunnel is tunnel 2. So that which tunnel is active, that's telling you which data path the device is using to send traffic. In our next section, we're going to discuss the system monitor. This document is really intended for a hands-on sitting together going through this. So there is some complex math within this section that we're going to talk about a little bit, but then I'm also going to direct you to a Techncial site where you can get some additional information. And all of these documents will be sent out so you can go through some of these things in a little bit more detail. So we're going to talk about the system monitor operation. We're going to discuss the rules and sort of how it works, discuss how the pass-fail criterion is determined within the device. and then we're going to walk through a basic setup. So the system monitor allows you to detect network errors and then execute rules. So you have the ability to say, if my uplink Ethernet network goes down, and you can test out to a remote site. You're not testing the physical interface on your device, on your IpTL device. You're actually testing the data path. So I can set up a remote server and I can send ICMP packets, or I can do web requests, and I can determine that the entire path of the network from my IpTL device to some public server is good, is passing or is failing. If it fails, I can execute rules. And so I can define, I want to add a static route to the device. I want to add an IP address. I want to delete an IP address. I want to add a VLAN, send an email alert. So you're monitoring the network between your device and some public location, and then you can execute a set of rules, whether you're in the pass state or the fail state. There's a very good document on Techncial, and we have the links kind of embedded in here that you can go, and has a lot of this information, and it walks you through the setup. So from a high level conceptual view, on the left side, I have a test. So we create a test and we tell it, I want to send ICMP packets to this public IP address. If I start losing packets, I can execute profiles. So if I go into a pass state, I execute a profile. If I go into the fail state, I can execute a profile. And then within each of those profiles, I can have any number of user-defined rules. So if I go into the pass state, add a VLAN and put this IP address on that VLAN. If I go into the fail state, I can add a different VLAN. I can add VLAN 201 and add this IP address on it. The clear profile is anytime you change states, it will run the clear profile. And a lot of times we don't even define a clear profile. But in this scenario, the clear profiles, anytime he goes from a pass to a fail or fail to a pass, anytime he changes states, I have him clearing out all the VLANs and all the IP addresses. So the first thing that we're doing is we're going to create a network test. So the system monitor is built around this concept of network tests. So I can create up to 20 different network tests, each with completely independent profiles, independent tests, determining what they're connecting to. With the test type, I can monitor a tunnel. We can generate ICMP packets, or we can generate HTTP requests. So you can have the device actually doing web requests to a public web server to check that that's still available. Once I define my test, then I can create profiles. And you can name the profiles anything you want. So I can say, network is good, or network is bad, or LTE enable, LTE disable. But you're basically creating these profiles, and then within the profiles, we're going to put rules in. The rules, we are constantly adding more and more rules. This is the example set from when we defined this document. So I can add or delete static routes. I can change the default gateway on the device. I can flush all the gateways, add IP addresses, add or delete VLANs, generate SNMP trap. It's a lot of different things that you can do when you set up the system monitor. So to create a system monitor test, first thing I do is I create a named test. So you can give it any name that you want. I can say, I'm testing for my LTE, or I'm testing for, my overall network. Once you create a test, you're going to get a block for configuration, and that block is going to be based on that name. So if you have multiple tests, they all have a unique name. When you go down through, each of the different configurable variables has a little pop-up window to give you information on what that configurable criteria is. So at the top end is sort of controlling how our test is going to work. We can enable or disable the test, generate an email alert. You can send the monitor log, and we'll talk about that. It's a log that the system monitor itself is maintaining to determine pass-fail criterion, how many packets have been received, how many packets have been lost. You can also send the device log, which is if you go to the web page and you hit log, that is the device log. So you can send that along. And the device log gives you a good historical view of what's happening within the device. So if you get a failure and you send the device log, it kind of tells you what had happened leading up to that failure scenario. There's a couple different test types, whether you choose ICMP, HTTP, or tunnel. It will give you a different set of variables that you need to configure. So when you do ICMP, we generate 3 ICMP packets each test interval. HTTP, we generate 3 HTTP packets every test interval. For tunnel, we're basically just monitoring the state of the tunnel. You can define the monitor criteria. So with my test intervals, we can set up how often we send ICMP, and we can generate the test period. So in this scenario, I'm saying every 2 seconds, generate ICMP packets or generate HTTP packets, or every 2 seconds, monitor check the state of the tunnel. The test period is over what period of time do we determine if it's good. So if I send 3 ICMP packets and missing 2 coming back, I don't necessarily want to go into the fail state and then 2 seconds later get 3 good packets and go back to the pass state. So what we're doing is we're creating a test period that we're monitoring the system so that I can get some drop packets here and there, or you can set it up where no drop packets are acceptable. If you get a drop packet, go into the fail state and stay in the fail state. So if my test interval is 2 seconds, and this is what I was talking about, we gets a little complex as we get into here. So some of this you can come back later and kind of think through these. But if my test interval is 2 seconds, that means every 2 seconds I'm going to send 3 ICMP packets. So I'm sending 6 ICMP packets. I'm sending 3 ICMP packets every 2 seconds. I'm monitoring 20 seconds worth of information. So that means I'm going to have 10 tests run over that 20 seconds. So you end up getting 10 tests. Every test you run, you send 3 packets. So it's 30 packets for that test interval for that 20 seconds. And that's all based on your configuration. So now if I look at the system monitor tracking, I can see my current period. I've sent 30 packets. I've received 30 packets. My current hour that I'm looking at, I'm getting 100%. I've got 405 packets sent, 405 packets received. So within the system monitor, you can go in and check your current stats. You can check longer running stats. If you're running it for 24 hours, you can see the last 24 hours. So if you're monitoring your uplink to a public server and you get some outages overnight, you can come back and take a look. Okay, at 2 a.m. we saw this many missed packets. So the pass-fail criteria is based on a percentage, the percentage of packets that we have received during our test. Typically what we like to do is set up your pass criteria is like 90%, your fail criteria is 60%. And again, we're setting up a hysteresis so that we don't oscillate back and forth. What we're trying to avoid is a configuration where you're constantly going from a pass to a fail. So you enter the pass state when you go above the pass criterion. So if our pass criterion is 90%, we will enter the pass state after we go above a 90% pass. If we're then running and we start dropping some packets and we get down here, let's say we're at like a 70%, we're still in a pass state. We're below the pass criterion, but we haven't gotten lower than the fail criteria. So once we go below 60%, now we're in the fail state. And then let's say we recover and we're starting to get packets, somebody fixed the network, whatever the issue was. We get back up to the 75% packets received, we are still in the fail state. And we'll be in the fail state until we pass the 90% packets received. Depending on how you configure your system monitor, you get a different set of options to configure. So if I set it for ICMP, I get my test interval, test period, pass-fail criteria. If I set it for tunnel, to monitor the tunnel, I get a test interval. And that's how often I'm checking my tunnel. I get a tunnel index, which is which of the tunnels. So if I set it to 0, I'm monitoring all tunnels within the device. And I get the option for a hold off. So my hold off is how much time to wait and recheck. So If a tunnel drops and then it gets reestablished immediately, I may not want to generate a fail criteria. I may want to only go into the fail state if the tunnel drops and doesn't come back immediately. So I can say every 2 seconds, check my tunnel state. If I go into a fail state, if I determine that the tunnel is down, I'm going to wait for 30 seconds and then recheck my tunnel. If after 30 seconds, the tunnel is still down, then I go into a fail state. If 30 seconds goes by, I recheck my tunnel and it's up, I just stay in the pass state and make no changes. So it just allows you to monitor, did my tunnel drop based on some network error somewhere upstream for me, but immediately came back? I may not want to go into a fail state based on that. So once you create your profiles, the profiles will be part of the drop-down box. So I create my profiles, they'll become part of the drop-down box. So if I create 3 profiles, pass profile, fail profile, clear profile, they will all be part of the drop-down box then. And then I can assign one of them to the pass, assign one of them to my fail, and assign one of them to my clear. So now you're defining how your test really operates. So I have a target IP address, or I can put a URL that we resolved. So I can put a public server like an 8888, or maybe I put the public IP address of where my server device is located. If I put a URL in there, when it gets resolved, it'll automatically fill in the real IP address, which is the dotted quad IP address that gets resolved to. I define my next hop. So this is the path that I want to send my traffic to monitor this network. So if I've got an Ethernet port that I'm monitoring, my uplink Ethernet port going to a gateway, and then I switch my device, I go into a fail state and I switch the device, and now I'm running over LTE. The next hop tells the device, hey, keep sending these ICMP packets out the Ethernet interface. Don't send them out the new LTE gateway. Send them out that same Ethernet interface so that I can determine when that comes back. So that's how I determine that the network has been resolved. I need to go out that same path. Source IP is typically not used, but if you had multiple IP addresses on your uplink, multiple IP addresses on your system interface, this is a way of telling the system, hey, I want you to ping this IP address from this IP address, from this source IP address within our device. So now I have a complete system. I've got a test. I've created profiles. I can create rules into my profiles. When you create your profiles, you're basically just naming it. So there's a little block for create profile. You can just say pass profile, hit submit, and it creates those. So if I did that, I would have a pass profile and a fail profile. Neither one of them has been assigned yet, and there's no rules in them. Once I create my profiles, then I can determine which of my rules I want to use. When you select the rule from the drop-down list, the device will automatically present you with the information that it needs to operate that rule. So if I say I want to add a route, I can pick which profile, and it'll tell me, hey, I need a destination IP, a net mask, and a gateway, and a metric. If I decide I want to add an IP address, then it'll just say, okay, I need an IP address and a net mask, and I need to know what interface you're going to put that on. So this is the set of rules that are available within the device. So I can go through and I can say I want to add a VLAN. I can say I want to add VLAN 101 to the system interface, and then I want to add an IP address onto that VLAN. So this system.101, this is our nomenclature for saying it's a system interface with a VLAN 101. So even though this VLAN does not actually exist in the device, I can select it as the interface to put my IP addresses on. Once I add those two, now you can see the rules within your profile. So now I have a profile. It has, if I go in, if I execute this profile, I'm adding a VLAN 101 to the system interface. I'm going to add an IP address, 192.168.99.1 with a net mask onto that VLAN interface. So within this profile, even before I assign it, I can delete the whole profile. I can clear the results as the profiles get activated and deactivated. These little pill buttons on the side will either go red or green, telling you that the rule was executed correctly and added to the system, or the rule was not able to be executed. I can set up my rules and I can activate the profile. So before I assign it, as I'm going through and configuring everything, I set these up. I can activate this profile and verify that the rules get added and look like they're supposed to within the system, and that the system runs during that state. So at a high level, once you get everything done, you can see the test is running. I can force a failure scenario. I can delete the test altogether. I can activate my test. And then we have a couple of different logs that are in here. The first log being our system log. So this tells me any change of state. It's all date encoded. So I can see that this is for test 1. I've got a pass profile. I've got a fail profile. There's no clear profile assigned. The pass profile doesn't have any rules. Fail profile has 2 rules. It's an IC&P test, and then you can see where it starts. There's a failure detected and then a pass detected. And this will just continue to monitor and allow you to see what's happening in the system. So there's a couple different logs that show you different information. So the system log really gives you a change of state, an overview of the test, and then here's where I went into a fail state, here's where I go into a pass state. I can also do a drop down on here, and it gives me more of a detailed packet-based view of what's going on with the test. So these will continue to be updated. Gives me my current hour, my overview, how many hours have been logged, and then here I can see my time-stamped hours. So every hour that you run the test, it will add a new link. I believe it runs up to 72 different hours. It'll maintain the last 72 hours. But you can see I get a good test history. I can see I had some packet loss in hour 5. I had some packet loss in hour 13. So an example for on Techncial, there's an app note that walks you through monitoring an upstream network and making local changes. And that's part of the Techncial link in the beginning of this, in the beginning of these slides. The next thing that we're going to look at is the system tools. And this is a pretty short section. We're just going to walk through this just so that you are aware of the different capabilities for debugging issues that you see or verifying the operation of the system. So a whole bunch of tools that are available. So we can send pings. It will automatically update and give you information on the ping results. You can define how many packets you want to send. Source IP address, again, if you have multiple IP addresses within the device, secondary IP addresses, I can test how the traffic operates based on the different source IP addresses. We can also set up do not fragment and packet size. That's for determining MTUs and determining your MTU across a longer path or across a tunnel. We do Traceroute just to make sure that your traffic is being sent where you expect it to be if you're in a compulsory tunnel mode, or you want to go across a bridge tunnel and see how your traffic is getting out through the network. We can do packet dumping. This is sort of like a Wireshark or a TCP dump. This is very helpful when you're running in a server device and your tunnel's not being established. This will tell you if your issue is associated with your port forwarding rule. So you can see here, we're looking for any traffic coming in on port 5150. I'm seeing packets. So that tells me data is going from my external network to my internal network through my port forwarding rule. So if I have a tunnel that's not being established, that means that the issue is somewhere else. Network mapping is a very important feature that we have. I use it extensively. It's basically, I can set up a network. So I can say I want to do a search for 192.168.2.*, or I can put it in a /24 notation, and it will go out and do a scan on that network. So this is extremely helpful when I'm setting up a bridge tunnel connection. And now I should be able to access devices in a single network on both ends. I can run this and I can determine, yes, I'm reaching devices on my local side of my tunnel, and I'm reaching devices on my remote side of my tunnel. In the lower right corner on every single web page is the option to set up a timed reboot. So if I am working on a device remotely, and I need to change some IP addressing within the device, and I'm concerned that making these changes could lock me out. I could lose access to that remote device. Typically what I will do is I'll save the configuration. I'll say reboot after 5 minutes. I'll make the changes. If I mess something up, or if the gateway is not what I expected it to be and I get locked out of the unit, after 5 minutes, the device will reboot and come back into its last saved configuration. And that allows me to get access to the unit and understand what happened there. But it's just a nice tool to make sure that you can get back into a unit and you don't lose access to a remote unit. By default, all our devices connect into our support system. It's a TLS tunnel. This allows our tech support to get into the device remotely. So if you have 2 devices in 2 geographically different locations, and you're setting up a tunnel and you're having a little bit of issue, and you send an email into support, we can go through the support system, look at the devices, look for configuration issues. We can set up a team viewer and walk you through configuration on your actual device. The devices all support an email alert. So you can send an email on boot, you can send an email on tunnel issues. Within the system monitor, anything that you're monitoring within the system monitor, you can generate an email alert. Within this Techncial page, it kind of walks you through the configuration options. It also walks you through setting up a custom email. Yeah, I think the example that's in there is using Gmail as a custom email to generate email alerts. So you can set up your own email address for your device generating alerts. You can set up multiple secondaries on any of the interfaces within the unit. So I can go in and just set up multiple IP addresses. I can create a VLAN. I can put multiple IP addresses on that VLAN, or I can create multiple VLANs with their own IP addresses. We talked about the system monitor. Within the devices, we also support virtual routing tables. So I can have a detach multiple interfaces. They all have their own virtual routing tables. And then I can set up virtual routing table rules to say, hey, any packet that is marked 5, I want to send that to this virtual routing table. And that's how we would direct different tunnels in a bonded failover scenario or a bonded tunnel scenario. So we would direct those tunnels out different ISPs. So that section was really just an overview of the tools that are available. I don't expect you to be able to go and use all of them in detail. They're pretty intuitive. And there's information on our Techncial site regarding those. So the last section that we're going to go over today is the authentication system. So we're going to talk about the authentication system, how to create new users, configuring user access, and then the different system views. So the authentication system within the device, when you log in for the first time, there's an admin, monitor, and a user password. And those are the default passwords, but I can create a new username. So all my devices in my network, they have a custom username. And what this allows you to do is I can create my own username, my own password, and the device doesn't even include an admin, a username called admin, or a username called monitor. So I can create a new user, Gary. I can set up his password. By default, any new user has monitor level access. So they have read-only level access within the device. Once I create a new user, he shows up in there. That is a link that you can go in and configure that user. I can also go through and delete the admin, the monitor. I can create any of those users and create just my own custom users. So once I go into, so on that previous page where it said Gary, that's actually a link. When I click on that, it gives me a landing page for the configuration of this user. So I can set up a new landing page. So your landing page is, if you log in and you're just using the IP address or just using the URL, if you don't have any actual page, this is sort of the default page that you will land on. So typically on my devices, anytime I log in, I want to go check the tunnel status. So I'll set tunnel as my landing page. You can determine whether the header is visible across the top of the page, whether you have link access, and whether you have write access or you only have read access. So in this view right now, if I logged into this device, I'd go right to the home page. I'd be able to see all the links, but I would have monitor read-only access to each of the pages. There's also user attributes. So user manager means that this user can create and delete users. So when you go through a scenario, so if I set up a user named Gary and I want to delete my admin password, I log in as an admin, I create the Gary password. I have to set that password, my new password, as a user manager. So if you delete your admin and you haven't set somebody else as a user manager, then you don't have anybody that can create new users or change passwords on a device. A tunnel manager allows me to give sort of an engineering level to the tunnel page. So I can give a user read-only access to the tunnel. So you can't change tunnel parameters like who I'm going to connect to, or on a server, I can't change the listen port or any of those things. But a tunnel manager can set up a circuit ID. So I can have somebody that can monitor my tunnel page. He can go up in and change different circuit IDs, change parameters like that, parameters that don't affect the data path. And then we also have some filter views, which we'll get into. So I can set up a user where he logs in, he lands on the tunnel page, headers are visible, links are visible. He has write access to the tunnel page, but read access to everything else. And by setting this up, all of my links and everything are visible across the top of the page. And I'll show you a configuration where those are gone. So I can also set up where a guy only has tunnel access. So when he gets to it, he lands on the tunnel page, the tunnel header is visible, he has write access to it, and the page is visible. And what that looks like is he logs in, and this is the only thing that's across the top of the page. I can also set up where all the headers are visible, but there's no links available. And when we do that, you can see all the headers are visible like they normally would be, but I can only link into my tunnel page. User attributes for each of the users that you create in the system, you can set up user attributes. So like we talked about, the user manager can create and delete users. The tunnel manager can configure tunnel parameters without having write access to the tunnel pages. And then tunnel filter view allows you to set up some filtering. So I can create clients. So let's say I've got a server and I'm hosting multiple client devices. I can give my clients access to log in to look at the tunnel pages and give them different filtered views. So in the top, I'm logged in as an admin. I can see everybody. But let's say I have a test view where he can only see devices where the circuit ID says test. So in this view example, what I'm doing is I'm saying, I want to filter based on the name or based on a string that's in the circuit ID. So I could put customers' names in the circuit ID, and then I can filter out based on that. My other option is I can filter based on authentication. So I can go in each of these devices on my server has a little config pop-up. I can go in and check off this device is viewable by the admin, the monitor, the user, and Gary, but it's not visible by demo. So if somebody logs in with a demo password, they just will not see that line. And then you can look at, so in my admin view or my filter by authentication, this guy logs in, he's got a different username, and he can only see this one device. Within each of the pages, so the tunnel, networking, those are the headers across the top. Within each of those headers, I can actually configure which pages underneath those headers are visible. So I can create, if I have networking and I have everything on, when this user logs in, he sees all of the information, all the links are available down the left side. I can also create a user where he can see the overview, he can get to the system interface, he can get to the DHCP server. So maybe I don't want him to be able to access the routing table or the wireless interface within the device. So now when this user logs in, he's got a small set of information that he can access for that username. So that is everything that we had for today. We have another session coming up, session 3. Make sure that you register for that. We're going to get into configuring tunnels. Actually, we're going to walk through some tunnel configurations. We're going to talk about routed tunnels, bridge tunnels, IP share tunnels. So that's where we start getting into really how you're going to go about connecting your 2 networks together, or multiple networks together. We will send out all these slides you can go to that you can review. And please feel free to send any emails to support@iptechnologylabs.com. Thank you.